So this problem is, we want to solve the absolute value of x squared plus 2x minus 36 greater than 12. So this is an absolute value inequality. And so when you do an absolute value inequality, you have to think that the absolute value means two things. That this inside the absolute value could be greater than 12, or actually it could be less than negative 12, because when you take its absolute value, that would be greater than 12. So we actually have two inequalities here. X squared plus 2x minus 36 is either greater than 12, or x squared plus 2x minus 36 is less than negative 12. So we have two quadratic inequalities to solve. And since these are quadratic inequalities, what we do first is we subtract 12 from both sides. Oh, actually on this one, subtract 12 from both sides. And on this one, we're going to add 12 to both sides. And so we have x squared plus 2x minus 48 is greater than 0, or x squared plus 2x minus 24 is less than 0. So notice here we subtracted 12 from both sides, and on this one we added 12 to both sides. So remember, in a quadratic inequality, first we have to find the roots of each of these, and so we can factor this quadratic expression here, and also we're going to factor this quadratic expression on this side. So this one factors to x plus 8 times x minus 6, and so we let each of these equal to 0, and so the roots of this one is x equals negative 8 and x equals 6. Similarly, we factor this quadratic expression here into x plus 6 and x minus 4, and then the roots of this are x equals negative 6 and x equals 4. So we have four roots here: negative 8, 6, negative 6, 4. So all of those are roots. I'm going to divide up our number line. So we're actually going to have 5 areas to check because we have 4 roots to split up the number line. So let's do that. Let's draw the number line. So we have our numbers: negative 8, negative 6, and 4, and 6. And so these are our 4 roots here. And we're going to check numbers in between the roots to see if they satisfy the original absolute value inequality. So we're going to pick some numbers in between. So for below negative 8, I'm going to pick negative 10. And then between negative 8 and negative 6, let's pick negative 7. Between negative 6 and 4, let's pick 0. That's in between those two, a nice number. Between 4 and 6, we'll pick 5. And above 6, we'll pick like 7. So we're going to check each of these in the absolute value inequality. So if I plug negative 10 in here, I get negative 10 squared plus 2 times negative 10 minus 36. So that's 100 minus 20 is 80 minus 36 will give you 44. And so this is greater than 12. So that's true. So yes, that's greater than 12. So we can put a yes over here on this side. And so similarly, we're going to check each of these numbers. Let's check negative 7. So negative 7 squared is 49 minus 14. That will give you 35 minus 36 is minus 1, but you absolute value this, so this is going to be 1. Is 1 greater than 12? No, that doesn't work. So this area here between negative 8 and negative 6 will put no. So let's check the other numbers. If you check the other numbers, you'll see if I plug 0 into the inequality here, we get 36, which is greater than 12. So that means that's fine. The area where 0 is in is going to be in our solution. And if you plug in 5 now, you'll end up with 1. If I plug 5 in here, I'll end up with 1. That's not greater than 12. So the area with 5 between 4 and 6, that's not in our solution. And then finally, if I plug 7, 7 is coming from this area, into the inequality, end up with 27, which is greater than 12. And so, yes, that's going to be part of our solution, this area here. So what do we have? We have 3 intervals we're looking at. We're looking at the interval from negative infinity to negative 8, and then from negative 6 to 4, and then from 6 on to infinity. And they're all with parentheses, and they're all unioned. So how do we write that? So here we have negative 8 to negative infinity to negative 8, parentheses, union negative 6 to 4, negative 6 to 4, parentheses around both because it's a strict inequality, union 6 to infinity. So this is our solution. And if you wanted to look at a graph of this, graphically, what is this going to look like? So graphically, here we have the absolute value looks like this kind of W, x squared plus 2x minus 36. Remember, that's never negative. So it's kind of like this W that hits the x-axis. And here's the line y equals 12 here. And we want to know where the absolute value of this function is greater than 12. Well, we can see wherever it's above the line. So first of all, right here, it's above this dotted line here. I drew it as a dotted line. But right here, so that would be at our first point in -8. Then it drops below the line. And then right here, we could see -6, it goes back above the line all the way up till we reach here, which is 4, right here. And then it drops below the line again, and goes up again, and at x equals 6, it goes above that horizontal line. So that's graphically what we're talking about. We're talking about the areas where that graph is above the line y equals 12.